welcome to the 13th meetup of the Feature Store, Global Feature Store Meetup. It's organized by Hopsworks. My name is Jim Dowling, and I am CEO of Hopsworks. And today we have Venkata Pingali, and he's co-founder and CEO at Scribble Data. And as I mentioned, we had a chat about feature stores 2 years ago. So they've been in the space for quite some time at Scribble Data. They recently raised money, so they got a bit of publicity around that, and they're doing new stuff in the space, so which is really exciting. So they're trying to look at this space called sub-ML, and I think I'll let Venkata explain what that is exactly. So that's it for today. I'm just gonna hand over to Venkata. There's going to be a Q&A afterwards. You can ask questions in the Q&A button on the webinar. There is a chat button, but you might end up sending the chat just to panelists, and so it's easier if you just stick with the Q&A button if you want to ask questions. A little bit about Feature Store. We have featurestore.org as a kind of a community page and a Slack where you can discuss feature stores. There is a conference. It's going to come this year. October the 11th is the planned date for it. And we're going to open the call for speakers within the next couple of weeks. So if you're interested in giving a talk about feature stores or feature engineering or anything related to data and AI, please consider submitting a talk proposal. Without any further ado, I'm going to hand over to Venkata, and you can take it from here. So that's it for me.
Thank you, Jim. Let me pull up my screen. Can you see my screen?
Yeah, we're good to go.
Okay. Thanks, Jim, for inviting me. We have been relatively quiet for the past year and a half or so, where we've been exploring a bunch of different ideas around this problem space that we are calling sub-ML. And I'll talk a little bit about sub-ML, how we understand it, and what does it mean to actually design feature store for this subspace, and the direction that it has overall taken us in. I would love to hear your thoughts. This is the first time actually where we are talking in at a design level or an architecture level about this sub-ML. I will speak for about 20-25 minutes or so, and then we can open up for the question and answers. So far, so good. Jim? Okay, I'll assume that everything is good. Okay, a little bit about Scribble Data. We are a young startup. We've been fairly focused on the feature stores for about 2.5 years now. We have a couple of offices. Our primary office is now in Toronto, and I work out of Bangalore in India. And we have customers across multiple geographies, sectors, and things like that. And we are actually narrowing down our focus to a particular subspace called sub-ML. I'll expand on it. And we look at it holistically, both from a system standpoint, data science, as well as the business standpoint. So you'll get a little bit of flavor of it. The talk is meant to mostly share the high-level thinking around our product, but I won't get too salesy about it. If anybody is interested in actually deep diving into the specifics of the product and things like that, you please get in touch with me offline, and we can set up a conversation. I'm really keen to have any feedback that you may have on all of this. With that, let me straight away jump into what this Enrich feature store is. We have a particular interpretation of the feature store, which basically looks like a very modular full stack setup. Full stack means we go all the way to end consumer, in this case, the business user. And we do it in a way that is Lego-like, composable, and also continuously evolvable. At the core of it, if you strip out everything, the whole structure is built around a Metaflow-like service at the core, which is mainly focused on feature engineering. So it has a number of elements that are only about this. And we have been, doing this work for the past 2.5 years and so on. So these are, the core is fairly stable now. And much of our focus has shifted to what we think of App Store. We'll talk about that also, why that has come about. With that, let me jump into what is the problem space, right? What are we looking at? Now, if you look at the data science use cases, things that are more complicated than BI, involving some amount of feature engineering and some amount of modeling. If you look at the use cases, what we find is that every organization has a choice to make. Whenever a business function like sales or marketing, compliance, they come to the table and say, we want to solve this problem, they put it in two buckets. They put it either in the priority bucket or maybe bucket. Priority bucket means, let's say if you're an e-commerce customer, the search is a priority project. You basically put the best of your team on it. And these are all long-term projects with fairly complex infrastructure. And anything that is not in priority but gets put into this maybe bucket. These look like a lot of decision support kind of problems. Let's say you're looking at fraud in a marketplace that tend to have these kinds of problems tend to have second and a third priority level within the organization structure. The most fascinating thing for me is that actually organizations seem to have an intuitive idea as to where to draw these dashed lines. Right, we talked to a major, multi-tens of billions dollar e-commerce, and this top line is at around 30%. That means 70% of the projects fall into maybe, and there are many projects that just not worth it from a cost structure standpoint. So they fall into the not important category. Now, the interesting thing is that when we look at how this has evolved, this economics has evolved over the past few years, what we find is that the 30% is becoming 20%, 20% is becoming 15%, and so on. And what were not important, a lot of the things that used to be done on Excel, they're all scaling up and graduating into the maybe bucket. And this band, that middle band that we are actually seeing is the fastest subspace of use cases. Now, what is an example of this top level priority, right? I talked about for this e-commerce company, it could be pricing, it could be search, it could be personalization. And the maybe could be, fraud, recommendations, some kind of budget allocation, and so on, right? So this space, which is anywhere from, depending upon the organization, we seem to see anywhere from like 50 to about 80% of the use cases fall into this category called sub-ML. This is our phrasing. And it seems to resonate with a bunch of people. Ever since we started talking about it, we got a lot of feedback. For example, the last weekend we were speaking to a global bank, and they put something like 70% of their data science use cases within this sub-ML category. And let me, these are some examples that we have seen. We have done 50, 60, 70 use cases over the past couple of years or so. And we see use cases in various dimensions. It could be metrics, it could be pricing, reconciliation, and so on. The interesting thing is that the basic data science lifecycle seems to apply to all of this. There is a feature engineering, there is modeling, some combination, and this is a continuous process with all the checks and balances, right? Except that it is simpler than what we can think of as the big ML, the ones that are that consume a lot of data, that are operating in near real time, and so on. Let me give you a very concrete example. we have a payments customer. The customer actually runs a two-sided marketplace. There are partners on the left side and partners on the right side. And essentially what they want to do is that this is a highly volatile market. And what they would like to do is to manage the flows in this marketplace effectively. For that, they need to deeply understand what the partners look like, how their behavior is structured, and from there run a bunch of lightweight models that will highlight important partners that need attention. And then there are some workflows around it. Let's say you find that there is a particular partner is behaving in a very unusual way. That has to trigger a bunch of activities. Somebody will pick up a phone call or a phone, or somebody will write a message, or somebody will investigate it more, and so on. And we see this structure where there is a combination of feature engineering, then there is modeling, and then there is a final consumption layer, which is the data app. And this should start giving you a flavor of how and why this space is different from the traditional feature stores and the modeling that you may be familiar with. Whereas, so I call the ones that we are familiar with as big ML, and I'm defining this category called sub-ML. In what way is it different? The first thing is that the users are very different. The users in the case of sub-ML tend to be more of business analysts. They tend to have multiple personas within the organization. Whereas you require a fair amount of skill, machine learning, engineering skill, and data science skill to be able to operate a high performance, low latency feature engineering system. The other thing is that we are dealing with small, wide data sets. We are less than 10 terabytes or so. Whereas the big ML will look at much higher scale, much higher speed. And one important thing is this timelines. Whereas our traditional machine learning projects have an open-ended timeline, or they tend to go on for months at a time, because of the sheer each iteration itself takes a lot of time. It's natural for the big ML use cases to go into 6 months, 12 months. That is not unusual. Whereas the partner benchmarking like situations that we have seen, we operate on extremely tight timelines. We are looking at 5 days to maybe 3 weeks or 4 weeks. And it has to be, the whole effort has to be completed within the use case has to be done within the 3 weeks time period. And they're very sensitive to information because they actually act on the output of the feature engineering as well as the models. There are real world consequences when they actually act on it. So auditability is like an entry level requirement, deep auditability, right? Every step of the way, so that they can actually double check all of these numbers before they make the call. And because these are more of business users than the traditional users of big ML, who happens to be machine learning engineer and so on, the interface, the primary consumption interface is an app, a high-level app that will actually surface all of this information. So what I'm trying to convince here is that 70% of your use cases are actually in this category called sub-ML. And the sub-ML, the requirements are structurally very different from that of ML. And this is, initially we started by thinking about big ML and how to help large-scale deployments and so on. But as time progressed, as our product got deployed in multiple organizations and we were able to see what was happening, our understanding, the understanding that emerged was that there is actually a second and a third design point within the feature engineering space, and we expect more design points. And the nature of the feature store that you build for the sub-ML is going to be very different from the big ML, given all of these requirements. And this is what led us to a very different design. Our single most important goal for us was the speed of delivery. End-to-end, the use case has to be done. That means that we have to make a number of trade-offs that will actually delay or make it more difficult to build out a proper solution. For example, we started looking at primarily small and wider data sets, which have probably from a transformation and a feature engineering standpoint, they may be more complex, but from a purely resource management and complexity of operation, they are simpler. And we started looking at the long tail of the data use cases instead of the highest performance use cases. And the need in all of these cases is that once the use case is done, it needs to be ready to be used every single day. So we built the entire stack. When we started about 2.5 years back, when we told customers that, look, the feature store is really meant for curating and managing the life cycle and the serving of this data set, they said, no, I mean, we don't have separate teams to be able to do all of those things. And even if we engage them, that is like another 3 months of delay. The whole thing has to be done within like 3 to 4 weeks time. And therefore, we started going more and more full stack, like bringing the data closer and closer to end use case. And there are other elements like auditability, reproducibility. These are not just a requirement. We immediately get caught if it is not, if the numbers are not very auditable, right? And they have other concerns like tacit knowledge management and things like that. So what this all led to is a design point for us where we are looking at simpler overall design just to be able to make it nimbler. We had to make it very modular because every use case, every situation was a little different. So it was almost like a Lego blocks. We had to scale with skill. So we had to make it simple enough to get the first use case out, and the later use cases can be more complex. We chose not to be in the feature store. We chose to focus on features and not the store, because all of this data was quite sensitive. So, and then there were a number of governance concerns around the data. So we decided to use whatever is the host organization's storage structure, whether it is database, S3, they determine what the governance model is. And we ourselves started making the whole feature engineering process relatively stateless. So there is almost nothing on the server except for a fair amount of metadata, right? So hopefully this has convinced you that this is a slightly different design point. I will just jump into a few details and give you a glimpse. So our feature store or feature app store actually consists of two subcomponents. There is an app store component, and then there is a feature store component. The feature store should be relatively familiar. I'll also talk a little bit about the app store. At the core of the feature store, like any other feature stores now, we have this notion of transforms. They are fairly generic. They look like a module that takes a bunch of data frames from the state or anywhere else, and then generate a bunch of other data frames. And then over a period of time, because we have seen very simple to very complex transform, the amount of flexibility that we needed within the transform to be able to operate effectively was kept on making the transform more and more beefier. We have ability to conditionally execute modules, pre and post validation at every step at a data frame level, and we have checkpointing. We have state management that is capturing fair amount of the metadata, and logging. So for example, in the case of logging is actually a fairly central capability. And one reason is that what we found was that you spend almost 10x the amount of time debugging than actually writing the original feature engine code. The bugs in the feature engine are very expensive. And therefore, we spent quite a bit of time in our system to make it very, very transparent and to find bugs and to fix them really, really fast. That is something that we focused on from fairly early on. And then because of the different, because we have probably written hundreds of these transforms or helped write them, we found that there are all kinds of transforms, custom, pre-built, dynamically constructed. They keep, there is message passing between these transforms and things like that. So this is at the core of it, and then around it we have all the standard pieces that are necessary to run the pipeline: orchestrator, scheduler, performance manager, version management. All of these things are there. We again, execution API. These all should be fairly familiar, except that our overall deployment is designed to be fairly compact and fast. So we do both a VM deployment as well as a small number of Docker deployments, right? But we try to keep it really simple so that we can accomplish our speed objective. It's not the speed of the computation itself, but the speed with which we are able to address the use cases. That is critical. And the transform looks something like this. You can see a few elements. Basically, there were a few different approaches that we could have taken. We initially started down the decorators and that path and found that it was getting very cryptic and very difficult. So we went back to a plugin like or a class structure. And this is a HelloWorld transform. It is doing something very, very simple, which is loading up a data set and then logging this data set. When you actually execute this, can you see my screen? Is this visible?
Yeah, we can see it. We can see it.
Okay, the run is also visible, right?
No, we can see definite method. We can see the process method, and then we see at the bottom provider equals
okay.
transform.
So let me let me reshare my. Wanted to show you how the actual system looks, the output looks, right? So this is on the demo site. You can also see it if you're interested. You can log into this service. We'll give you access to it. But the idea is that that simple transform code, that 8-10 lines, translates immediately into a production feature engineering pipeline, and we have a method by which we roll it out from the GitHub itself. Because one of the things that was very important from the get-go was that if you have to reproduce these pipelines, linking the data sets and any of the artifacts to the actual commits of the code become very, very important. So it's a highly controlled deployment process. And then there's a whole lot of metadata, fairly extensive, that actually shows you what all has happened in the life cycle of this particular system, this particular pipeline. It's very simple. Let me show you a slightly more interesting example. So here you can see a few things. The first one is that this HelloWorld transform now defines something called as extra args. What we find is that in order to run these pipelines with backfill, conditional execution, and things like that, some of these transforms can have almost like 10-15 parameters, various kinds of thresholds, various kinds of filtering rules, and things like that. It has the core, the transform base class has an ability to handle a bunch of these things. And then one other thing that you will notice is this make note business, state.makeNote in line number 14. So one of the most important thing that we realized is that one of the sources of problem is that these feature engineering pipelines make decisions quietly. to handle nulls and drop records and reformat a bunch of fields and things like that. And that is these quiet changes are causes significant headache down the line. So there are the feature engineering transforms have the ability to note all the important decisions, and this get pushed to the end users who are managing these pipelines to make sure that they are seeing the most important things that have happened with respect to a pipeline. And then there is a bunch of stuff, including extensive state management. With that, let me switch over to the App Store. This was somewhat of a new thing for us. We started with one application, two applications, and very quickly realized that there are ever-growing number of apps. We have some 25 different apps that are coming out of the box for us. The idea is that the moment the data set is available, you can stick an app. Think of a low-code system with some 50, 60 lines of code. You can stick a full search interface in front of the data set. And over a period of time, we had to develop the app framework, the interfaces, and start supporting the kinds of workflows that users need in order to actually act on the feature engineering and the model data set. And it has its own API and things like that to do a variety of things. The apps actually, when we looked closely at the apps, we find that there are actually three kinds of capabilities that are required. The first one is all the things that you need to actually build an effective pipeline, something as simple as catalog. Very few customers actually have a catalog, and we can't do feature engineering without a catalog. So one of the things that our system comes out of the box is like a catalog is there to begin with. And it can do a few intelligent things like crawling of the databases or your sources and gather some initial information, just enough for you to be able to start capturing your tacit knowledge as well as using it in your feature engineering pipelines. Along with that, there are a bunch of other lightweight systems, applications that will enable you to build these pipelines really fast. All of these things, they're all geared towards the three objectives that that was there right on the front page. The first one is if you're doing this feature engineering, do it with high degree of trust and auditability. Gear this, structure this whole system towards value. How fast can you actually solve the end user's problem? And the third one is that do it really, really fast, right? And all of these, we start building these out to chip away at each of the friction points that we were having, and we kept on expanding the pipeline execution system to do automatic profiling, throw up a audit search engine very easily, and so on. So this is an example for that partners. The right-hand side, that is the Gori, the pipeline structure. On the left-hand side, you can see an app. It's a simple app. It's not designed to be a replacement for a full-fledged application app. But the key thing is that it makes the data consumable immediately. And the customers really like this thing and are pushing us towards more and more complex apps over a period of time. And over the next 12 months, we actually spend a lot of time on the App Store, cleaning it up and making it more widget and more low code over a period of time. And of course, a bunch of stuff on the transforms. And we are doing more and more deployments. And our, although we started with small data sets, the data set sizes are also growing. So we are having to accommodate more complex deployments. And we are also looking at more out-of-the-box integrations. We are in talks with a bunch of different platforms to be able to do these integrations. So with that, let me hold off here. I hope you got a sense of what SubML is, what we are trying to do, and how that has informed our journey. And I would love to discuss this in more detail. We can do it offline. We have a few minutes now, and we can pick up the conversations later on. Just search for my name and you should be able to find me on LinkedIn.
Thank you very much, Venkata. It's very interesting. I'm going to kick off with a couple of questions. So I wasn't quite sure what SubML would be, and I was very fascinated. And I think, correct me if I'm wrong, is SubML Python? So is the world, because we get a lot of feature store, that are talking about, the new data stack and the new, being SQL and Snowflake and so on.
Yeah.
But do you think that this 75-80% of use cases are going to be data scientists who do the feature engineering in Python?
That's actually a good question, something that we have spent a lot of time thinking about. So basically, when we look at the transforms, right, that are actually powering this SubML, they tend to be fairly complex, because the fundamental reason is that they are embedding a lot of domain knowledge that organizations have, lots of business rules and so on. And the pandas code is very messy. I don't see how that can be expressed as SQL, right? I don't see. Right, I've looked at the code. Right, the expressiveness of SQL is not enough. So what I've been telling users also is that if it can be done in SQL, there are plenty of systems. You should just stick to it. The reason our kind of systems comes into picture is there is some complexity. You are probably doing a probabilistic match between like different data sets. Right, that is a very common use case for us. You are probably running as lightweight model in the background and then servicing that as a feature in itself. I don't see, based on everything, I mean, we have implemented a fairly large number of use cases. I'm not seeing those being expressible as SQL. So I see this as complementary. Whatever you can do in SQL, just use it, because that is still the workhorse. That is the cheapest way of doing things. Come to ours when there is some reason for why you can't do it there, and you can't get to your centralized data team. If your centralized data team is bottlenecked and so on. So for example, we're talking to a fairly large e-commerce provider with 100 people data science team. Even with that sized team, they have a long tail, hundreds of these use cases that are lying unsolved. And all of them look like the partner benchmarking, right?
Fascinating. And where do you think then PySpark or even Flink fit into this world, or do they not fit into the world? Do you think there's going to be the people doing the large aggregations on their data warehouses, and then the SubML will be all Python, and PySpark will be just a legacy kind of technology? Or what's your take on it?
That is, you're putting me on a spot there. So
it's okay. I mean, like, I'm a big Python fan myself. I think Python is going to be a huge part of the solution. I think the original feature stores like ourselves, we were Spark as well, heavily influenced.
Yeah.
Other ones.
Even a lot of the Spark is moving to Spark SQL instead of PySpark. Yeah. Right now, once you move to Spark SQL, then Snowflake, like a system which provide a large-scale distributed or even high-performance SQL, that should take you a long way. For us, the reason we hesitated getting into PySpark and so on is most of our customers don't have the data engineering capabilities to run large PySpark clusters. That is the first problem. And the second problem is that the single most important objective that we have is use cases. We want to get them done as fast as possible. And that my academic background is in distributed systems. That would be naturally where I gravitate. But we have tried to make hard choices in order to accomplish our speed objective. And one of the choices is keep it, single server. And servers today can handle large volumes of data. That is not a problem by itself. The distribution adds a lot of complexity, and it dramatically increases the skill level of the users, which I don't know if I will find or not find in the customers' environments.
Cool. I have another question about because I really like the combination of apps and feature stores, but I have a question here. Maybe I'm missing something. Like for me, an app is like the way you presented it. It's something that might run 24/7, or maybe you spin it up and then you turn it down. But you talked mostly about batch models as well in the background. Now, if you're going to make your app intelligent, it kind of needs access to the model 24/7, right? Or it needs, while it's running, or maybe it's going to be embedded, or maybe you think the app should be in some model serving infrastructure. Is that something that you're going to move? Or what's your take on that? Like,
good question, actually. So I spent some time thinking about what are these apps? Why are they coming to begin with? Why can't end users do it? So the interesting thing, there are two interesting elements of this app store. Now, what it is turning out is that the features that we are actually preparing for machine learning, if it really has signal, it is of interest to lots of other stakeholders in the organization. This is one way of surfacing that information to another class of stakeholders, in this case, business analysts and so on. So that is the first one. But more interestingly, what are they doing with this, right? What we think is that they are driving their decision workflows using this. They're actually looking at this data, analyzing it, slicing, dicing in whatever way, and finally making a decision. They are not coming here to just understand the distribution. For example, in the case of partner benchmarking, the partner manager is coming to the table with a desire to make a decision that single day, right? So why you use this kind of an app is driven by at least these two things. It's interesting data, and it is actually crucial to their decision support. Now, the question is how real time or how up to date should the information be that is being presented, and should it be two-way, right? Is the individual actually providing some sort of steering to the whole backend and things like that? So what we are seeing is that steadily it is getting closer and closer to real time. Right, we are getting to hourly updates and those kinds of things. We are hesitating to put a full real-time service there, because that requires a fair amount of attention. Right, it is something that we have to commit both from the customers' end as well as from our end. We have to commit resources to make sure that that is actually a very robust thing. So what you are seeing here is actively we are making trade-offs. We are going to do this and not this on a continuous basis. And until recently, we were outside the modern stack. We wouldn't fit into the modern stack. Now, if you look at the latest updates to the modern stack, whether it is coming from A16Z or Foundation Capital, we are bang in the middle of the stack. The conversation there has moved to the point where they are now bringing these multiple personas into picture. They're bringing use cases into the conversation. They're talking about data apps. They're talking about these improving the productivity or time to delivery and things like that. So today we think that Enrich is fairly close to the center of what we would think of as the evolved modern stack. And I think it is just a reflection of the fact that we now have accumulated experience. Right, the narrow framing that we had from about 2.5, 3 years back, it is being revised with all. I think,
at least in the app side, A16 care about Streamlit. There's a big exit there. I think they were bought by, and they're an apps, and then we have Gradio, I think now by I can't remember who are they called again. The company who do the pre-trained models, Hugging Face. Yeah, they have a Grado, but that's more notebook-centric kind of apps. But really cool. Look, thanks, Venkata. It's been fantastic having you here, and great to hear about your new journey with SubML. And I think it resonates with me anyway, and Python, of course, resonates with me heavily. So we'll be looking forward to hearing more about you in the near future. And I guess you can tell people how to reach out to you guys.
Yeah, please reach out at Pingali, which is my last name, at scribbledata.io, or you just Google on LinkedIn and you can find me. I'm looking forward to presenting this, because this is slightly off the beaten track, and it is definitely stretching. It stretched our own thinking, and I think we are having very active and engaging conversations with the data science community now. So I'm hoping that to submit a presentation at your upcoming conference.
Fantastic. And yeah, just a reminder that's going to happen. But the video for today will also become available soon. I think, Mariana, it'll be available with the next newsletter. And for people who register, we'll get an email about it soon, I believe. Thanks, everyone. Thanks for attending. And have a great rest of your day, wherever you may be.
Thank you.
Thanks, Venkata. Bye.
Bye.